When people compare Kubenet and Azure CNI, the discussion often starts with a checkbox mentality. Which one is faster? Which one is simpler? Which one should I pick? But the framing misses the real point. Choosing a CNI is not selecting a feature. It's signing a network contract that defines how your entire cluster integrates with Azure networking. This contract determines how pods get IPs, how traffic is routed, and whether your cluster behaves like an isolated system or a first-class citizen in your virtual network. The important question is not which CNI is better. The real question is, what network contract does my platform actually need? Kubenet creates a very specific network model. Pods do not live in your VNet. They live in a separate address space, typically something like 10.244.0.0/16. When a pod sends traffic outside its node, Linux IP tables perform source NAT. The pod's IP is rewritten to the node's IP. From the perspective of the VNet, pods doesn't exist, only nodes do. This model is simple, lightweight, and efficient with IPs. And for small or experimental clusters, that can be perfectly fine. But the contract is clear. Pods are not route table entities in your network. Everything goes through translation. Everything is indirect. Once you accept this contract, everything else makes sense. Routing, observability, private endpoints, and limits. Azure CNI signs a completely different contract. Here, every pod receives a real IP address from the same subnet as AKS node. There is no NAT, no translation, no hiding. Pods become first-class citizens of the Azure virtual network. They are routable, they are visible, they participate directly in VNet peering, NSGs, and routing. This model consumes more IP space and requires more planning, but in exchange, the network behaves predictably, especially in hybrid, enterprise, or security-sensitive environments. This is not just a different implementation. It is a different philosophy of networking. This is why Kubenet versus Azure CNI is not a performance discussion. It's a contract discussion. With Kubenet, the contract says, pods are internal implementation details. With Azure CNI, the contract says, pods are network participants. That difference affects observability, security boundaries, private endpoints, on-prem connectivity, and future platform services. You can't switch the contract lightly. You definitely don't want to discover its implication after your cluster is in the production. Most problems don't appear on day one. They appear when the platform grows. When you introduce private endpoints, strict NSGs, platform services, or hybrid connectivity, the networking model suddenly matters. With Kubenet, pods are not first-class citizens of the VNet. They live in a separate address space, and every packet leaving the node is translated. That means private endpoints never see pods. They only see node IPs. Load balancer never target pods directly. They always go through the nodes and kube proxy. This works, but it also means observability is indirect. Security boundaries are coarser, and debugging becomes harder as the system grows. Scalability is not broken, but it is constrained by routing limits and operational complexity. Azure CNI changes this contract entirely. Pods become routable entities inside your VNet. Networking decisions align with how Azure actually works. That's why CNI is not a feature toggle. It's a network contract that defines how your platform behaves under real production pressure. Terraform makes switching between Kubenet and Azure CNI look trivial. One variable, one apply, but Terraform does not change the contract. It only enforces it. The real decision happens before the code, at the architecture level. Once you understand that CNI is a network contract, not a feature, the choice becomes much clearer and far less risky. This is how AKS networking stops being magic and starts being intentional. This design note was not about Terraform syntax. It was about architecture before implementation. In real systems, failures rarely come from missing resources. They come from wrong assumptions made early. Networking boundaries are not an implementation detail. They define what your platform can safely become in the future. This is why design notes come first. They clarify intent before code exists, before modules are reused, before systems scale. The blog post that follows shows how this intent is implemented in Terraform. The course that shows how these decisions play out across a full AKS platform. When intent is clear, Terraform stops being a collection of resources. It becomes a compiler for the architecture. That's how production-grade systems are built.